Hi everyone. In the given problem statement of is subsequence, we are going to solve the problem where we are going to given two integers s and t. We have to ensure whether s is a subsequence of the t. So here let me type in s, which is going to be a, b and c, and t value could be something like a, h, b, g, D and C. We're going to take two pointers with I pointer and J pointer to be 0. So for example, in this first case, right, A, B, C and A, H, B, G, D and C. Initially, both of the pointers would be at the initial position or 0th position. If A and B are same, then we are going to increment both I and J by 1. So now our pointer is going to be at B and our J pointer would be at H. Now whether B and H are same, it is not same. So in that case, right, we are not going to increment the ith pointer, but we are going to keep on incrementing the jth pointer. So our jth pointer would become 2 and it is going to go to that B position. Now in this case, both of the pointers, the value, right, B and B are same. So now again we are going to increment the ith pointer by 2 and jth pointer by 3. And we are going to go to the third position. And similarly here we are going to go to the fourth position. Now C and G are not same. So we will be incrementing it again. And D and C would be not be same. So we are going to increment it again. And here, right, we're going to reach to Cth position. And here the value is same. So because currently our I value would again get incremented, so I would become 3. And the length of S is equal to the I, so we can return true. In, for example, take us this example, AXC, AHB, GDC. Initially both are same, so we're going to increment it. Now we go to the X position, so H is not same as X, B is not same as X, G is not same, and again D and C is also not same. So here, right, if I look into the pointers, right, it is at the first pointer. Okay, so length of S is basically 3, and our pointer, right, is just at 1. So both of them are not same. So it's not equal to, so we are going to return false in this case. So basically using two pointers we can solve this problem with ease. Now let us jump to the Python solution. Now for the problem, let me initialize two variables, n1, which is going to be the length of S, and n2, which is going to be the length of our second string t. Now if we get a value, for example, if n1 is 0, in that case it will always be a substring, right? So we are going to return true. Now we are going to create two pointers. So initially I and J, both of them are going to be 0. And let me type in while jth pointer is less than n2, and also our I pointer is less than n1. Now we are going to check whether that string or whether that value in that position is similar. So S of I is equal to T of J. In that case, we are going to increment both I with +1 and J with +1. In case it's not, then we are just going to increment the jth pointer by +1 as we discussed. Now once that is done, we're going to check whether our ith pointer right has reached to its last position or not. It will only to reach to the last position if all those values are present in the t in the correct order. So now if I equal to n1, we are going to return true, else return false. Very simple problem statement. And if I look into the time complexity, it would be big O of n. So here we are just looping through that entire toString only once. So you can say it could be big O of or 2 big O of n, or you can simply say big O of n would be time complexity. Now let me submit it for all the private test cases, and as you could see, it beat 100% of the submission. So our code is pretty efficient. That's all for this video. See you in the next one.